There's something mesmerizing about the rhythm of giant factory machines, yet some offer a spectacle beyond mere efficiency. They ignite pure awe and are utterly incredible. Join us as we show you 20 of the most satisfying factory machines that will amaze you. Number 20. Crayon-Making Machine. The automated crayon-making machine exemplifies industrial ingenuity applied for artistic ends. Through a sequence of efficient mechanical processes, it converts raw materials into colorful wax writing implements beloved by children worldwide. Observing its hypnotic rhythms as pigments transform into crayons is fascinating. The machines mix and melt paraffin wax with precisely metered amounts of powdered pigments in huge vats to achieve the desired hues. This liquid wax is then poured into thousands of mold cavities in cooled trays. The wax rapidly solidifies into the iconic crayon shape. After the crayons have fully hardened, automated punch devices push them out of the molds, and inspection systems discard any imperfect specimens. The finished crayons slide through sorting and packaging equipment to be labeled, wrapped, and boxed for shipping. Modern crayon labels even reflect the color of the crayon inside. From blank wax to brilliant crayons tumbling down chutes, the automated process blends art and engineering to produce a childhood staple. The machines tirelessly extrude endless colorful varieties around the clock. Their output exceeds human limitations, churning out crayons in volumes enough to inspire creativity in millions of children. Each stick contains boundless artistic potential waiting to be unleashed on paper. What automated ingenuity yields, young minds can craft into beauty. Number 19. Pipe Twisting Machine. The mesmerizing pipe twisting machine is a surprisingly simple but highly effective device used to bend and shape metal pipes. Watching it deftly twist sturdy steel rods into ornate spirals and screw thread shapes is extremely satisfying. The machine makes bending and manipulating rigid metal look as easy as twisting pipe cleaners. The basics of the machine involve feeding metal rods through a small hole or die, and then twisting them. This turns the straight rods into spiral, helical shapes. A heavy flywheel provides the power, pulling the rod through the die, which forces it to conform to the spiral shape under high tension. The distance between the threads can be adjusted by controlling the ratio of the die's rotation speed versus the rod feed rate. Fast and slow, coarse and fine threads can be produced for different purposes. Though deceptively plain-looking, pipe twisting machines require tremendous force to deform the metal. Flywheels weighing several tons deliver the necessary torque, with the die hole carefully machined to precise diameters. The metal rods are locked in place to prevent whipping as they are twisted. Different materials like stainless steel, aluminum, and iron can be shaped. The intricate spiral components created find many uses, such as decorative railings, gates, furniture, handrails, and even medical implants. The predecessor to pipe twisting machines was blacksmiths laboriously twisting rods manually using repeated heating and hammer strikes. The machine made this intricate work simple, fast, and consistent. The hypnotic twisting action never fails to impress. It's a metal-forming skill made easy. Number 18. Hot Wound Spring Machine. Few things are more mesmerizing than watching the hot wound spring machine gracefully form springs from red-hot metal rods. The machine heats steel or carbon rods until they glow bright orange at over 2,500 degrees Fahrenheit. The workpiece is locked in place as the machine pulls the heated rod through a spiraling path, coiling it round and round into the familiar spring shape we know. After cooling, the spring has taken on its bouncy, flexible properties. The process looks almost magical as the molten metal is effortlessly curled into perfect coils before your eyes. The hot winding technique makes strong, resilient springs able to withstand repeated compression and extension cycles without taking a permanent set. That's why springs made this way are used for demanding applications like engine components and suspension systems, where performance is critical. They outlast weaker cold wound springs. Heating softens and stress relieves the metal so it can be formed tightly without damage. There is an art to adjusting conditions just right to avoid overheating yet allow ideal plasticity for coiling. Traces of oxidization on the cooled springs add appealing rainbow hues. The automation eliminates the need for blacksmiths to shape springs through repeated heating and manual hammering manually. Its hypnotic dance as it winds perfect springs is timeless. Number 17. Automated Cartridge Filling Machine. There are few things more soothing and satisfying to watch than the automated cartridge filling machine in action. Its smooth, precisely choreographed motions as it expertly fills cartridge after cartridge create a sense of calm and well-being. The repetitive operation becomes almost zen-like. These versatile machines are used to fill all manner of cartridges, from printer ink cartridges to e-cigarette vape cartridges. Their accuracy and speed far surpass human abilities. An array of mechanical arms adroitly handles the cartridges as integrated pumps or reservoirs dispense the required liquid into them without spills or messes. Some models can fill over 15 cartridges per minute or 900 per hour, a feat no human could match without quality suffering. The mechanical hands have a delicate touch, deftly handling the small cartridges like a master jeweler polishing a precious gem, and the steady metered doses of liquid dispensed into each container are a display of unwavering precision. Watching the machine repeat the process flawlessly every few seconds induces a meditative state from its smooth, rhythmic motion. No energy is wasted or fumbling caused by human shortcomings. Number 16. Metal Casting. The process of metal casting bears a striking resemblance to the mystical art of alchemy. It transforms crude ores from the Earth's depths into virtually any conceivable object through the simple acts of melting and pouring into carefully crafted molds. This ancient, almost magical process has produced ritual artifacts, tools, weapons, machinery, and more for thousands of years. Observing it creates a portal to past civilizations. The earliest known castings date to around 3200 BCE, when the naturally occurring lost wax technique was used to cast copper amulets, jewelry, and figurines via molds made from beeswax. It was a serendipitous discovery that one of Earth's basic elements could be melted, poured, and shaped. Casting advanced in China around 700 BCE, with the first cast iron arriving in Europe via trade routes around 500 BCE. Iron's higher melting point required technology like bellows. Cast iron-infused construction projects like medieval cathedrals and colonial cities. The Industrial Revolution's demand drove casting's scaled-up mass production. Watching raw ore transform into molten metal glowing orange and swirling like lava captures casting's almost supernatural aura. It is an elemental transmutation, bending nature to human will through fire and molds. Even today, observing the fiery liquid metal flow into forms, from engine blocks to art sculptures, carries visceral impact and historical resonance. The automated process that advanced civilization arose from humble origins by experimentally shaping the Earth's raw essence. Number 15. Chain-Making Machine. Few processes better illustrate effective teamwork and synchronization than the modern chain-making machine. While chains seem simple, their continuous interlock design means producing them is a meticulous step-by-step process requiring precision. By breaking the tasks into separate stages and mechanizing them, the automated chain machine churns out strong, durable products rapidly. The amazing machine combines various functions such as straightening, bending, punching, pressing, and welding metal rods into chain links. Each stage does its specific job as the components move through the production line, with the links progressively taking shape. The collaboration of the mechanisms to create a finished chain is impressive. Raw iron, steel, or aluminum rods are the starting material. They are straightened if coiled, since any kinks would weaken the final chain. The feed mechanism inserts the rods into the bending presses, which mold them into curled C and O shapes. Punches form holes for assembly. As they advance through heating stations, interlocking links are welded together. Finally, the completed chain is cooled, lubricated, and conveyed for storage or shipping. The machine embodies an almost organic vitality as it efficiently transforms raw metal into an interlaced finished product. The synchrony of its motions captures the essence of engineering elegance. Watching it work is visual music. Number 14. Hosc UMC 750 Machine. The Hosc UMC 750 machine is an engineering marvel that combines digital precision and software-guided flexibility with the versatility of human craftsmanship. This computer numerical control unit can accurately shape metal, wood, plastics, and composites in up to 5 axes of motion. Watching it contour complex forms is like viewing a master machinist at work. The machine's precision cutting abilities almost seem intelligent as it deftly carves intricate designs. However, behind its performance lies advanced proprietary software developed by Hosc that guides its movements in concert with user input. Increasingly powerful algorithms allow it to optimize tasks and motion control sequences. The servo motors driving its axes offer finely tuned control. This allows smooth contouring of the most challenging geometries to tolerances of a few thousandths of an inch. The sight of UMC 750 is reminiscent of seeing a master machinist at work. The fluid motions as it shapes parts are mesmerizing and reminiscent of hand skills. Yet examining the end results reveals a precision no person could replicate consistently. The Hosc UMC 750 represents the future of manufacturing, integrating automated technological prowess with human ingenuity and creativity. Each complements the other to achieve a whole greater than either alone could produce. Number 13. Balloon production. The creation of balloons dates back centuries, with the first rubber balloons appearing in the 1800s. But it wasn't until the 20th century that balloon manufacturing became automated. Observing these efficient machines produce countless colorful balloons is a fascinating glimpse into the process. At facilities like the popular Pioneer Balloon Company, the balloons start out as liquid latex rubber, which comes from rubber trees. After extraction, the milk-like sap is combined with curing agents and dyes. It is poured into tanks, where dipping form assemblies are mounted on conveyors. As they cycle through, a layer of the colored latex mixture coats each form. They slowly build up the balloon shape through repeated dips. The forms have tiny air holes, so air pressure prevents the balloons from sticking as the latex coats them. The balloons are then cured in hot ovens, which bake the rubber. Conveyors carry the coated forms through the curing ovens. Watching the mesmerizing conveyor lines of dangling forms moving through the latex and into the curing ovens is fascinating. The dripping balloons in an array of bright colors are eye-catching. The efficiency of the automated process is impressive compared to laborious hand assembly. The machines choreograph the process from liquid latex into cured, colorful balloons. Their speed and precision exemplify industrial ingenuity, creating simple joy. Number 12. Noodle Factory. Ramen noodles are a favorite quick meal for many across the globe. While the basic process of making noodles has remained largely unchanged for centuries, factories today use advanced automation to mass produce them. Observing these hypnotic machines in action provides insight into how billions of packages of noodles are created each year. It all starts with mixing flour, water, salt, and an alkaline salt, which gives the noodles their springy texture and yellow color. These ingredients are blended to form a dough. The dough is then put through a rolling machine to flatten it into sheets. Cutting wheels slice the sheets into noodle strands, which are the ideal thickness. The noodles then undergo steaming for 1 to 2 minutes at temperatures up to 240 degrees Fahrenheit, which partially cooks them through the starch gelatinization process. They are then coated in oil to prevent sticking. In factories, conveyors continuously move the noodles through steaming chambers on mesh belts. Next comes frying. The pan-fried noodles are fried at 320 Fahrenheit for 1 to 2 minutes. This dehydrates them for preservation and storage. In large factories, noodles are conveyed through continuous deep fryers, though batch frying is also used. The noodles are then cooled and packaged. In just minutes, raw ingredients are transformed into the instant noodles billions rely on for quick, tasty meals. The sight of automated factories churning out mountainous piles of perfectly cooked dried noodles is spellbinding. The machines work tirelessly with laboratory precision no human could match consistently. Of course, the output volume itself would be impossible to handle manually. However, the mechanical efficiency and synchronization are hypnotic. Line workers simply keep the system running as it clicks along like clockwork. Number 11. Bubblegum production. The automated production of bubblegum is pure confectionery magic. Raw, natural latex sap is transformed into rainbow streams of addictive, chewy gum through a process of purification, cooking, flavoring, and rolling. Observing gargantuan machines churn out barrels of gum is a sugar-fueled delight. The gum base starts as a viscous sap tapped from the sapodilla tree, native to Central America. Similar to rubber production, the sap is treated with accelerators and chemicals and concentrated into thick latex. This is the raw gum base. At production facilities, the base is pumped into huge kettles where it is boiled and filtered multiple times to achieve purity. Sugar and corn syrup provide sweetness. These are slowly mixed into the filtered gum base in measured proportions, along with fats and emulsifiers to enhance smooth texture. Exotic flavors from banana to blueberry are also blended in to tantalize taste buds. The flavored gum is then poured onto cooling tables in sheets, or extruded into tubes or ropes. It is heated under rollers that knead the gum to make it pliable before pressing it into the desired shapes. The gum retains impressions from engraved rollers that apply distinctive patterns. Finally, the gum is coated in powdered sugar or wax and packaged. Watching pure white bases transform into vivid hues and finally become gum in fantastical shapes thanks to the power of machines is magical. They epitomize industrial ingenuity, invented solely to tantalize children and childlike adults worldwide with bursts of flavorful chewing enjoyment. Their mechanical choreography captivates as they churn out delightful confections. Number 10. Egg breaker. The automated egg breaker and separator machine elegantly handles one of food manufacturing's most messy and tedious tasks: mass processing raw eggs for their components. Watching the fast, flawless breakdown is enzymatically satisfying. The mechanical system, through creative pneumatics and motion, separates thousands of eggs into yolks and whites in minutes for cooking use. A wheel mechanically cracks the egg perfectly against a plate, emptying the contents without shattering shells for easy removal. The fluid egg released slides down onto a sloped conveyor belt while shells are ejected. The conveyor separates the egg. Slots between belts let egg whites drop through into a collection tray. Heavier yolks continue sliding and are caught in their own tray further down. Clever engineering gracefully harnesses gravity and weight to divide the parts cleanly every time. No human hands can achieve this with such speed, efficiency, and hygiene. Egg breaking and separation used to be slow, labor-intensive kitchen work before mechanical ingenuity automated it. Today, these machines are a standard fixture of food processing facilities, their repetitive motion and ordered workflow resembling synchronous dancers. The adroit disassembly satisfyingly overcomes food production's messiest challenges through pristine mechanical choreography. Number 9. Braiding Machine. The rhythmic motion of the carbon fiber braiding machine, with its threads interlacing in a hypnotic pattern, evokes a sense of timeless craftsmanship, echoing the dedication of artisans from ages past. While textile workers once hand-spun fibers into clothing and artifacts, this huge apparatus ingeniously scales the process to build high-tech components. Its size and complexity evoke a cosmic loom, weaving matter into reality. The 9-meter diameter circular braiding device intricate carbon fiber patterns into components like automotive wheels. The machine has up to 144 spool carriers coordinating 48 strands each. A central robot arm oscillates to intersect the fibers in alternating clockwise and counterclockwise directions as they are woven. The hypnotic kaleidoscopic motions resemble devout rituals. Layers gradually build up as the fibers advance repeatedly through the intricate pattern cycles. Watching the infinite care and patience of the technology is humbling, contrasting humanity's frequent rush and urgency. Something with such vast scope operating so deliberately commands reverence. From the most ancient basket weaving traditions to massive braiding apparatus serving advanced industries like aerospace, human hands have been superseded, but the meditative essence of crafting by methodically interlacing strands remains. We once depended on such skills for survival. Now machines dutifully carry them forward. Their limitless intricacy honors fiber's legacy. Number 8. Orange Shaker. In the sunny orchards of Valencia, machines rove between rows, tirelessly shaking orange trees to harvest their fruit. Custom-fitted claws gently envelop each trunk, vibrating it until oranges rain down for easy collection. This creative solution brings efficient mechanization to specialized agriculture. Orange trees can produce over 500,000 fruits annually. Traditionally, harvesters climbed ladders to selectively hand-pick the ripened oranges. However, this is slow for high-yield varieties like Valencia's hardy, bitter-tasting oranges. While the oranges are inedible fresh, they are ideal for juicing. Tree-shaking machines vastly accelerate the harvesting of the oranges, which fall onto catch frames encircling the trees. The fresh fruit is rapidly transported for processing. A day's work picking by hand takes just minutes per tree now, and without ladders and climbing, safety is improved. The machines resemble gentle giants slowly cradling and rocking the trees like babies. Their motion blurs from soothing oscillation into productive vibration. The falling oranges evoke sleek autumn leaves shed in their season. There is elegant synchronization between machine and tree yielding its bounty. Each fulfills its purpose in recurring cycles, united in motion. Number 7. Avocado Peeler. The avocado has surged in popularity in recent years as a superfood and versatile ingredient. However, peeling and pitting them by hand is laborious. The automated avocado peeler and pitting machine is a game-changing innovation that effortlessly processes avocados at remarkable speeds. Watching it peel avocados as fast as one can eat guacamole is highly impressive. In machines like Food Logistics' avocado peeling machine, avocados are fed into a hopper and descend down a chute. Rubber rollers manipulate them towards curved blades that neatly slice lengthwise around the pit and along the circumference to separate the peel. The two peeled halves then enter a pitter to remove the core. An arm mechanism presses the avocado against a shearing device to slice out the pit, which falls away while the fruit is held in place. No avocado flesh is wasted. Finally, ejectors divide the pitted halves to drop into different collection bins for further processing. The machine can process up to 280 avocados per minute, far faster than humanly possible. And its actions are mesmerizingly smooth and efficient. The machine transforms the time-consuming and frustrating task of hand peeling into an automated process that is satisfying to watch with its graceful choreography and buttery green results. Its stainless steel sanitary construction is easy to thoroughly clean as well between batches. Number 6. Tree Processor. Forestry mechanization has come a long way from axes and crosscut saws. The modern tree processor fells, delimbs, and bucks trees into logs with minimal human input. Guiding these dexterous giants to harvest timber seems like controlling a creature from fantasy. Yet this fusion of machinery with nature's bounty is mesmerizingly productive. The operator uses a hydraulic arm equipped with a circular saw to shear through the tree trunk and drop it precisely where desired. The machine then grasps the felled tree with an array of metal claws. A delimbing knife rapidly strips branches off the stem. Finally, a second saw cleanly bucks the log into predetermined lengths for transport. The machine's robust hydraulic arm can rotate, extend, and maneuver logs with delicate control. Precision cutting maximizes value by optimizing configurations. The machine tames the formidable task of harvesting towering, multi-ton trees and reduces them to orderly prepared timber with just subtle joystick movements. Its graceful lumbering gait and dexterous arm synchronize the raw power of heavy machinery with finesse worthy of skilled axemen. Yet the results far surpass manual methods. The choreographed dance between man and machine to extract resources epitomizes mechanization's potential. Now it's time for today's subscriber pick. Few devices epitomize raw, destructive power quite like an industrial shredder. These colossal machines represent the tremendous might of modern engineering, obliterating everything in their grasp, from cars to appliances, reducing them to mere scraps of metal. There's a primal fascination in witnessing the irreversible finality of an object disappearing into a shredder's maw. Within seconds, its prior form is erased, fragments left unrecognizable. This fascination has led to a trend of using shredders for unusual, pointless purposes, merely for entertainment. For instance, one person threw a fish into a shredder. It's obvious that a machine capable of crushing a truck will easily pulverize a fish, rendering it finer than a minced fish. However, it's crucial to remember that wasting food is never a good idea. What are your thoughts on this growing trend of using shredders for senseless destruction? Do you find it fascinating, or do you believe it's a waste of resources? Let us know in the comments. Number 5. Pad printer. The ingenious pad printing process allows almost any object to be decorated, labeled, or branded with professional results. A simple hand stamp transfers ink to pads, which then print onto 3D items. From golf balls to circuit boards, pad printing mechanically enables precise image transfer that was once impossible or extremely difficult by hand. In pad printing machines, a laser-etched cliché plate imprints the desired image onto a silicon pad. The inked pad then contacts the target product. As it retracts, surface tension causes the ink to detach from the pad while adhering to the item. Shifting between the delivery system's planes enables applying graphics and text onto challenging objects. Compound curves, uneven edges, delicate materials, and tiny components can all be printed with precision. The pads even reach into recesses thanks to their flexibility. Machines adroitly decorating items of endless forms quickly and flawlessly is mesmerizing. The pad deftly navigates surface topography like a tentacle to deposit ink onto the most obscure targets. It seemingly imbues the printer with senses, adapting to each product intuitively. The technology's potential to brand almost any item or surface is virtually unlimited. Number 4. Road printer machine. Laying roads using traditional manual labor and machinery remains time-consuming and disruptive. But the road printer machine eliminates human effort by automating paving to rapidly print out new roads lane by lane. Using one is like watching a 3D printer crafting infrastructure from the ground up. The road printer is essentially a movable steel mold with a scraping blade that levels and compacts soil into a flattened, packed foundation. An onboard conveyor feeds bricks into the mold, which arranges them tightly together as it slowly rolls forward. The machine can lay down patterns beyond just bricks like cobblestones. An extra-wide model spans 2 whole lanes. Sensors and controls enable precise printing even around curves and corners. Ungrouted bricks are sturdy enough for immediate use after being compacted by vibrating rollers. The whole process is fascinating. It's like drafting with a ruler. The template ensures dimensional accuracy and smoothness. The speed and autonomy outpace human masons considerably while minimizing physically strenuous labor. Its reliability helps pavement get laid faster. Number 3. KWT Intrarex. Wood carving machine KWT Intrarex. T3000 is the marvel that carves intricate shapes rapidly from timber with stunning accuracy and fluidity. Watching it transform a solid log into an ornate table leg evokes visions of mythic beings effortlessly conjuring mundane reality from the primordial void. Where once carvers manually coaxed forms from wood with main strength, the machines summon animation forth with just flashing blades guided digitally through space. The KWT's 5-axis capability allows carving complex contours in all dimensions by adjusting angles unhindered. Rotating and tilting the stock fully during shaping unlocks organic designs impossible otherwise. Textures and contours flow seamlessly together as if emerging directly from a sorcerer's imagination into the wood's grain. Each routed cavity seems a window to an infinite cosmic dimension whose paths the machines intuit as they carve. Its computerized minds navigate landscapes where humans only wander blindly, tracing shapes our senses cannot fathom. It unveils nature's hidden forms through technology's alchemy. Matter yields its secrets to their knowing touch. Number 2. Cow hoof trimming machine. The cow hoof trimming machine is an ingenious invention that has made the arduous task of hoof trimming much easier and safer for both the cow and the farmer. In the past, trimming a cow's hooves was a laborious process that involved manually tipping the heavy cow onto its side, often requiring several strong men, and then clipping away at the hooves with hand tools. This was strenuous work and hazardous, as the cow could kick out if startled and injure the farmer. The hoof trimming machine eliminates most of this hard labor by mechanically tipping the cow onto its side on a padded bed on the back of a truck. The cow is strapped in for safety, with its legs secured so they are accessible. This allows the farmer to stand clear of the heavy animals and use power tools to trim the hooves efficiently. Studies show proper hoof care is vital for the cow's health, preventing lameness and improving milk production. Overgrown hooves can lead to pain and problems walking. The machine trims all 4 hooves evenly in minutes, a job that could take hours manually. Some may see the process as unnatural or stressful for the animal, but most video evidence shows the cows remain calm, indicating they do not seem to mind the experience. In fact, the farmers report the cows almost appear to enjoy their periodic pedicure by the machine. The smooth hydraulic action of the tipping mechanism is more comfortable for the cow compared to being wrestled into position by hand. Number 1. Laser rust removal. Restoring rusted items manually requires grinding abrasively to strip damaged surfaces, often removing healthy metal too. But laser rust removal eradicates corrosion precisely without harming surrounding material. Sweeping a laser over flakes of rust and watching them vaporize is supremely satisfying. High-power diode lasers emit infrared beams that excite rust molecules into breaking down instantly. The intense energy detaches just the corrosion and converts it into gas and dust. The base metal emerges clean and intact, unmarred by mechanical scrubbing. Laser rust removal excels where abrasion is unwise. Delicate antiques, stamped lettering, textured finishes. It eliminates the need for solvents or chemical dipping as well. The pinpoint accuracy of software-guided lasers allows clean superficial stripping without damaging good metal underneath. The laser's touch erases the blemish of rust, revealing gleaming metal beneath, a metamorphosis both dazzling and futuristic. Yet the beam works physical changes systematically, energetically overcoming bonds corroding compounds form. Guided manually or by automated scanners, it restores in seconds through precision, which grinding crudely approximates but degrades. Its clinical accuracy entrances. Our technologies realize intricate potentials nature obscures. Thanks for watching, and we'll see you in the next one.